All right, let's go through the first page. Three numbers. You have to add the two smallest numbers together. They're not in any order. That was the biggest problem with most of the students. They didn't understand they don't have to be in order. It's the two smallest numbers added together. So 14 is bigger than the third number, 8. So yes, it is a triangle. 7 8 is 15. 15 is bigger than 8, the third side, so yes. And then 3 and 6, those are the smallest numbers. They add up to 9. 9 equals 9, so no. That forms a straight line. And then 3 and 7, that's 10. 10 is smaller than 12, so no. Those two do not even meet to make a bridge, so that's what you're looking for. The other sides of the sides of the triangle from shortest to longest. So the smallest degree is opposite the shortest side. So make sure you read which direction you're supposed to be going. So the shortest side first. So KL is first. And then you have 44. That's opposite MK. And the order of the letters don't matter. And then we have, so these are segments. Doesn't really matter. Then 100 degrees, ML would be last. Okay, and then 650 is the smallest angle, so it's opposite ED. And then 65, those are both the same, so these two go together. CD and CE would be the next two shortest sides. Okay, however you want to label it. Angles. Now we're just talking about angles. And we're going from smallest to largest. So the smallest angle is opposite the smallest side. 14 is the smallest side. So angle W. Then 17, which is angle Y. Then 23, which is angle X. Number 8, 13 is the smallest side. So angle V. Then 23, which is angle T. Then 24, which is angle U. The largest angle. Round your answer to the nearest tenth. Make sure you pay attention. You'll be counted off partial points for those types of things. Interior angle sum. So n minus 2 times 180. That's all you had to do. So 11 minus 2 times 180, or 9 times 180. So 9 times 180 on the calculator gives you 1620. So that's what all the angles add up to, all the degrees, in a 11-sided figure. Okay, 21-sided figure, so 21 minus 2 is 19. Take that times 180. 19 times 180. You get 3,420. Solve for x. So in a parallelogram, opposite angles are the same. So 40x minus 2 is equal to 118. Just a side note, consecutive angles add up to 180. Okay, so if they're next to each other, they add together to equal 180. I notice there's not any of those on here. So we add to 40x equals 120. Divide off the 40, and this is what should be on your papers. Make sure they're on your exam. So x is 3. Number 12, these are the same. So 7x minus 7 is equal to 70. Add 7. Divide off the 7. X is equal to 11. Make sure you answer the question. All they're wanting is solving for x. They're not asking for anything else. Make sure you don't make that error on the test. Okay, same thing here, 13, 14. Opposite sides are equal. Please get off your phone. So I'm going to subtract x to the right. So 8 is equal to 2x minus 2. 10 is equal to 2x. And x is equal to 5. So just basic algebra solving skills. 14, 6x minus 2 is equal to 4x plus 6. Subtract 4x. 2x minus 2 is equal to 6. Add 2. Divide off the 2. X is 4. So diagonals bisect each other in a parallelogram. All right, so I'm just going to make this a little bit bigger. Oops. So that means that each of these segments of the diagonals are equal to each other. So RE is 3x, which means EP is 3x. And then it says RP, the whole distance, is 7x minus 4. So you have 3x and 3x, that's 6x. That's equal to the same distance of 7x minus 4. All right, so we solve. I'm going to subtract 6x. If I go to the right, that leaves 0 on the left. 1x minus 4 on the right. Add 4. 4 equals x. And that's the mistake most students make. And what was happening yesterday, the answer is not 4. X is 4, but that's not the answer. It wants to know what RE is. RE is the first segment here. That's 3x. Well, x is 4, so 3 times 4 is 12. That's where they get the 12. So that equals RE. All right, number 16. I'm going to go ahead and move all this a little bit. So KC, again, these are bisectors. So each of the segments are equal to each other. So KC is x minus 2. And CM is 2x minus 10. So there's nothing there that gives you the total like the last problem. These two are just equal to each other. So x minus 2 is equal to 2x minus 10. So subtract the x. You get negative 2. Please remember, I've said it all year. Please remember the minus sign doesn't go away. It just becomes the negative on that problem, that number. So that equals 1x. So 2x minus x is 1x. And you have a minus 10. I'm going to add 10 to the left. X is equal to 8, but again, you got to find KC. KC is just the small segment here. So KC is x minus 2. So we substitute 8 in. And so KC is equal to 6. All right. Here is a problem. This is an issue. The rest of these are ridiculous. Most of these are just parallelograms, squares and rectangles, but they didn't make any hard ones like what you had in your homework assignment. So let me go through a couple, and I'll just, these 4, and then I'll explain what I mean. So first of all, the best name for this is a trapezoid. No, I'm sorry, quadrilateral. Trapezoid has 2 parallel sides. There are no parallel sides in that. Okay, looks like a trapezoid, but you need 2 sides that are parallel. All right, so that is just a quadrilateral. That's the best name for it. All right, so now you have number 18, 4 right angles and 4 congruent sides. So that is a square, which I'm sure everybody thought was easy. Number 19, same thing, that's a square. And then number 20, that's a parallelogram. Okay, and as we go through the rest of these, they're very simple. But if I were to do something like this, first of all, what do you think that is? How do you know it's a rectangle? You don't know that. Yeah, of course you're going to say it's a rectangle. because that's what it looks like. Remember what you're supposed to learn in this class. You have to prove everything. So what does a rectangle have to have? It has to have opposite sides are parallel, which those aren't marked. It has to have four right angles. That's not marked. Okay? And opposite pairs have to be congruent in length. You don't have anything marked. So if I wanted to say this is a rectangle, all I would have to do is this. Rectangles have four right angles. If you have four right angles, then the opposite sides are congruent. Two pairs of opposite sides are congruent. If you want to call it a square, so we'll draw something that looks like a square. Again, the best name for this is a quadrilateral until I mark it. If I did this, you still can't say it's a square. At best, you can call it a rhombus. A square has to have two things. It has to have four right angles and four congruent sides, which is what those pictures have in 18 and 19. So you have to prove everything, and these pictures are way too easy. So we look at this, again, parallelogram. So if I drew the parallelogram like number 22, what would you say that is? You'd like to say it's a rhombus. But you can't because you don't know if the sides are identical. All four sides have to be identical. So in a parallelogram, opposite sides are congruent. But you don't know that all four sides are the same. All right, so again, the best name is a parallelogram, which is correct. This is actually, if you're going to be technical, you got to make sure that you understand why it's just a parallelogram. Number 23, that's a rectangle, even though it looks like a square. 24 is a parallelogram. $25, you're looking at parallelogram again. Again, they didn't. You got to make sure you know the difference between a rectangle, a rhombus, a square, a kite, okay, trapezoid. Your goal is to prove what it is you're saying. That's what you're learning. All right, then that takes us to the next page. So, all right, 27. The polygons in each pair are similar. Find the missing side length. All right, if they're similar, then you set up a proportion. Side is to side, as side is to side. So go the same direction and make sure you use the corresponding positions. Notice I didn't use this 8 because there's nothing here to put it with. You have to be in the same positions. And then we cross multiply. 8x equals 144. So divide by 8, 16. 144 divided by 8, 18, sorry. 18. All right, make sure you answer the question. It just says find the missing side length, so we just did. We're done. 28, same thing. Make sure they're oriented the same. It looks like they are, so 7 is to x, and then you just pick something else. 4 is to 12. Cross multiply, 4x equals 84. Divide off the 4, 21. Number 29, again, they're similar. Find the scale factor of the smaller figure to the larger figure. So we are going small to large. So what does that mean? For your scale factor, you're getting bigger. Nobody remember? Okay. So let's first of all figure this out. All you have to do is find corresponding positions and make one fraction. So this one doesn't go to anything. This one doesn't go to anything. These two go together. They're in the same positions. So we're using 30 and 12. The question is it 12 over 30 or 30 over 12? If you're getting bigger, the bigger number goes on top. So 30 twelfths, but then reduce it. So they are both divisible by 6, and you get 5 over 2. So 5 halves is the scale factor for 29. So they list it like this, 2 to 5. This doesn't help you in this form. Scale factors have to be written in a fraction form, because what do you do with scale factors? Scale factors are used as scalar multipliers, meaning they're just numbers that you multiply something else by. So if I took 5 halves times 30, what am I getting? I get a bigger number, don't I? Okay, well, isn't this the larger picture? So if I multiply by 5 halves, I'm asking for a bigger picture. But it says small to large, so I should have taken the 12 times the 5 halves, and that will give me 30. So it all depends on which way you're going. If I wanted to, let me erase a couple of things here. If I asked you, this is a good practice for you. If I asked you what that position was, and you didn't know any of these, I guess we should go the other way since we're doing what the problem is doing. Let's go with this one right here. And you don't know any of these numbers here. So you can't set up a proportion. But I give you the scale factor of 5 halves. So I give you the scale factor of 5 halves. All I have to do is take the smaller number times my scale factor, and that tells me what that is. 5 times 12 is 60, divided by 2 is 30. And doesn't that make sense that this is 30 as well as this one? Here's why. If these two are the same, those two better be the same if they're similar pictures. Okay? All right, let's do number 30. So again, we're getting larger. So notice which ones you have here, 18 and 15. Those are not the same positions. Make sure you use corresponding positions. Since we're getting bigger, the bigger number goes on top. 18 over 15. Reducing by 3, you get 6/5. And again, on the sheet it says 5 to 6. When we go through the exam.
The ratio? Is 5 to 6 the ratio?
Yeah, same thing. But it doesn't help you unless you know how to use it. Does anybody here know how to use this? Yeah. Again, you do, now that you've seen this, because I'm saying, how do I write this down as a scale factor? Well, I'm getting bigger, so the bigger number goes on top. If you wanted a smaller number, let's say you did. Let's say I wanted this one right here. I'd use 18 in this one. So if I want a smaller number, I'd put the smaller number on top and multiply it by 18. That's how you use it. Okay? All right. Find the missing side of each triangle. Simplest radical form. Don't round, use the Pythagorean theorem. Okay? So these two are your legs, and this is the hypotenuse. Remember what I've always said. If you have a right triangle, always identify the hypotenuse. That is always your C in your Pythagorean theorem. A squared plus B squared equals C squared. So A and B are interchangeable. So 6 squared plus X squared equals your hypotenuse squared. 36 equals 225. Subtract 36. x squared equals 225 minus 36. On your calculator is 189. So we take the square root of 189. So again, I'm just going to point out some different things. If I add those digits together, 1 plus 8 is 9, plus 9 is 18. The number 3 and 9 work the same way. Does 9 go into 18? Yes, it does. So that's divisible by 9. So 189 divided by 9 gives me 21. So 21 doesn't break down any further to something that is something that you can take a square root of. So yeah, it breaks down into 3 and 7, but you can't take the square root of those. Okay? Just practicing those numbers. Again, these are your two legs. This is your hypotenuse. Square root of 122 squared is 122 plus 14 squared. It's 196. 14 squared. Losing it. 196 equals your hypotenuse squared. So 122 plus 196 is 318. So it's even. I'm going to divide it by 2. And I get 159. Just check and make sure. And 159. If I take 1 plus 5 is 6 plus 9 is 15. 9 doesn't go into 15, but 3 does. So I know I can break the 159 down into 3. Gives me 53. 53. Is that prime? 53 is prime. 3 is prime. 2 is prime. So nothing else goes into it. So since those don't break down any further and you don't have any doubles, they just go back together. That's why it says square root of 318 for x. Okay, the last part of this page. Find the missing side lengths again. Leave your answer in radical simplest form. Special right triangles. Now, you could sit here and do the Pythagorean theorem again. That's fine. Did anybody use the special right triangle formulas? Yeah, 1 or 2 of you. Aren't they on the, are they the first page? Don't you have the formulas? Yes or no? Formula's not on the review?
No, we have the answers.
Oh, okay. All right. You do get all the formulas on the final. I know I have them. An old test. Okay, so there's nothing wrong with you using the Pythagorean theorem as long as you're not rounding. Don't use your calculator when it says not to do that, especially if they give you the answers in radical form. You still got to figure it out. Okay, so your 45/45s, those are just hypotenuse equals the leg times square root of 2. So you just plug those in. The hypotenuse is 5, the leg is x or y. Divide off the square root of 2. So x is 5 over the square root of 2. Except you shouldn't leave it like that, right? How did they leave it on your sheet? Yeah, you got to rationalize it. And in a 45/45 degree triangle, the legs are the same. So this also equals y. X and y are the same. So y on number 34 is 5 square root of 2. What's your hypotenuse? Again, you could use the Pythagorean theorem. I'll do it on this one. So your legs squared, y squared plus 5 square root of 2 squared equals x squared. So the only way to solve this with the Pythagorean theorem is understanding that those two legs have to be the same in a 45/45 90-degree triangle. So therefore, we have 5 square root of 2 squared plus 5 square root of 2 squared. It's the only way you could use the Pythagorean theorem, is that you understood those two legs were the same. So when you square that, 25 times 2, 25 times 2. So 50 and 50 is 100. So take the square root, x is 10. And you need to say that y is 5 square root of 2. That is what you would need to write down. If we do hypotenuse equals the leg times the square root of 2, your hypotenuse is x. The leg is 5 square root of 2 times square root of 2. Well, you have doubles there. That's 2. So 5 times 2 is 10. So I'm going to erase it, so if you need it, pause the video and write it down. Give me a little more room here. Number 35. Now we're using the 30, 60, 90 formulas. So I'll do this one with the formulas, and then we'll do Pythagorean theorem as well. You have 2 for 30, 60, 90. The hypotenuse is the short leg times 2, and the long leg is the short leg times the square root of 3. Hypotenuse, again, identify what that is. That's x. Short leg is y. So that doesn't help us. The long leg is 9 square root of 3. The short leg is y. And then we multiply that by the square root of 3. So divide off the square root of 3 to get y by itself. Y equals 9, and y is the short leg. So we put it into the other equation. 9 times 2, x is 18. On number 36, I'll use the Pythagorean theorem. Identify your hypotenuse. So each leg squared and you notice that you can't use the Pythagorean theorem. You can get away with it on the 45/45s, but you can't get away with it here. Okay, so you do have to use these formulas, and the formulas are given to you. So again, hypotenuse is twice the short leg. So the hypotenuse is u. The short leg is 9/2. So u is 9. The long leg is the short leg times the square root of 3. The long leg is v. The short leg is 9/2. Okay, so v is 9 square root of 3 over 2. All right, so number 37, SOHCAHTOA. The sign of x stands for the opposite leg over the hypotenuse. Hypotenuse is 37. Opposite leg is 12. 37 is prime, so 12/37 is the answer. Okay, then on 38, again, we're doing sine at corner C. The hypotenuse is 45. The opposite leg is 36. And those are both divisible by 9. So that gives us 4/5. So 4/5 would be the final answer. Now we're doing cosine of angle C, so we're starting at this angle. Cosine stands for the attached leg over the hypotenuse. So again, identify your hypotenuse. And the adjacent leg, which also means attached. What's attached at C would be 28. That's the attached leg. They're both divisible by 7, so it gives us 4/5. And 40, we're doing the cosine again at angle Z. Yes. So the cosine again, identify your hypotenuse, is 13. The attached leg at Z is 12. And that's already reduced. 13 is prime. All right, number 41, tangent. So tangent at corner Z. Identify your hypotenuse, 35. But tangent doesn't use hypotenuse. Tangent is the opposite over adjacent, SOHCAHTOA. So the opposite leg to corner Z is 21. The attached leg at Z is 28. What are those both divisible by? 7. So 21 divided by 7 is 3. 28 divided by 7 is 4. So 3/4 is the answer. All right, 42. Again, tangent. Where are we? We're at x, so we're at this angle. So the tangent of x is, again, the opposite over adjacent. The opposite leg is 40. Identify your hypotenuse. And the attached leg is 9. So 40 over 9. Okay, so central angles, when they're attached at the center, are the same degree as the outside part of the circle. So that answer is just 115 degrees. Again, what is this piece? 130. It's the same as the central angle. Okay, so these are just finding the degree angles. So it's no longer starting at the center. So if it was, this piece right here would be 144. But it's not at the center. It's back at angle L here. And this angle is always smaller. Look at the two angles here. Angle L versus this angle at the center. Obviously, angle L is acute if you look at it. This is an acute angle versus this angle right here. This is obtuse. So that should help you understand if you're doubling or taking half. Because that's what you're doing when you're doing these types of things. So we're taking half of 144. So the answer should be 72 degrees, which it is on the back page. And the last problem. So angle F is half of this arc, so 40 degrees. And it does tell you inscribed angles. Inscribed means the angle's on the circle, not at the center. That's a central angle. What they don't have on here, and they should, is what do you do when your angles are outside? So we did inside, now we're doing, and we did on, now we're doing outside. Anybody remember how to do these? Yeah. So let's revisit it. If it's outside, you're subtracting arc A minus arc B. So A minus B, let's call that X. And you take half of it. Subtract those and take half of it. That equals that angle, that outside angle. Okay, if you have your angle on the inside, anybody remember what we're supposed to do? So arc A, arc B, so angle X here. X is equal to 1/2 of those two angles added together. Those are just your basic formulas. The inside makes a plus sign. Outside you have two minus signs, okay? So you're taking half of all those unless you have a central angle. Okay. All right. All right, number 47. Find the length of the segment indicated. So X is 2 because anytime you have a perpendicular line going through the center of your circle, that splits that chord in half. So X is equal to 2. So we go to the next one. Same thing, you have a perpendicular line going through the center of the circle, so it splits that segment into 2 equal pieces. So X is 10. All right, center. The center of the circle is always opposite the values given. So that's positive 3 and 19 halves. The radius is always the square root of the answer. So that would be 4. Same thing on this one. Your center is at negative 4, positive 16, and the square root of 1 is just 1. So now let's go backwards. Given the center and the radius, again we do the opposite number, minus 4, positive 13, and then we square the radius to get this value. 4 times 4 is 16. Okay, same thing here. Writing the formulas. Positive 10, so that's negative 10. Positive 8, that's negative 8. And we square 5 to get 25. Okay, now the length of the arc. The length of the arc is to the circumference, pi times your diameter, 22, as the degree is to the whole circle, 360. So we cross multiply, but instead of taking 225 times 22 times pi, let's treat pi like a variable, like it's x. And so you're going to take 225 times 22, and that gives us 4,950 pi. Now, in general, if you're just answering the question, go ahead and multiply it by pi on your calculator. But if you have multiple choice, like on some of the questions on the test are multiple choice, and we already know what the answer to this is, it did not include what pi was. It left pi as a variable. So what that means is we have to go ahead and solve for the arc length by dividing off the 360. And instead of using the value of pi, we're just going to leave it in our answer, and we're going to reduce that fraction. All right, so you need to watch for that on the test. I've not looked at the test, so I can't tell you that that's the way it's going to be. Okay? So you need to know both. Obviously, you can still figure this out as a decimal, but just in case, you got to do it like this. So we're going to reduce both these by 10. That gives us 495 divided by 36 times pi still. And that is still divisible by 9. So 9 goes into 49 5 times with the remainder of 4. And then another 5. 9 goes into 36 4 times. So the answer should be 55 pi over 4, or 55 fourths pi. So you have to know how to reduce fractions. And that is the answer in the back of the book, back of the worksheet. Same thing on this one. Let's just go ahead and move everything over. The arc length is to the circumference, which is pi times the diameter of 16. The degree to the total degree. And we're going to solve this the exact same way. Okay, so what we want to do at this point is take 16 times 150. That's 2,400 pi equal to 360L. Divide off the 360. So again, we're just reducing the fraction by 10. And then we can reduce, let's see here, by 4. That's 60, and that'd be 9. Leaving pi in our answer. And then that reduces by 3 to give us 20/3 pi. So that's how you do it with just leaving your answer in fraction form and not using the pi button. Okay, so we're gonna do the same thing except with the area problem. So the area of the sector over the total area, pi r squared, in this case 16. And again, the degree to the total degree. So I'll give you a second to work that part out, and then we'll work through it. Okay, so again, you have 360 times the area of the sector, and you take 16 squared, 256 times 225, and it gives you 57,600 pi. And again, we're going to divide off the 360. And so we should always check 57,600 divided by 360 on your calculator. And it actually comes out to a whole number, so you don't have to sit there and try to reduce. So always try the first number just to see if it works. So that helps out. All right, let's do number 56. Same thing. So the area of the sector is 2 pi r squared, as the degree is to the total circle. Okay, so 14 squared is 196 times 60 gives me 11,760 pi. And that's 360 times this area of the sector. Divide off the 360. And so now we work on reducing the fraction. So reducing by 10 removes those zeros. They reduce by 3, so 1176 divided by 3 is 392. 36 divided by 3 is 12. Let's see here. They reduce by 4. 4 goes 392 divided by 4 is 98. 12 divided by 4 is 3. And that's it. All right. Find the volume of each figure. This is a box. So the volume of a box is just length times width times height. So 4 times 7 times 4. Okay. No matter how you do it. So 16 times 7, that's 70 and 42, which is 112 cubic centimeters. All right.
Yeah, he's gonna tell me it's weird.
It's a cylinder.
I knew it was a cylinder.
So the volume of a cylinder, again, is the area of the base times the height. So the area of the base is a circle, so that's pi r squared times the height. So the radius is 10, the height is 12. So on your calculator, you should end up with 3,769.91, and that's cubic feet. All right, let's go to the next problem. So now the question is, do you know what this is? It is a prism. Okay, it is a triangular prism. The sides of prisms are all rectangles, so that means those two triangles are the top and the bottom of your prism. So again, the volume of a prism is the area of the base times the height. Well, the base is a triangle, so that's 1/2 base times height times the height of the prism. So you have this triangle here. So 1/2 times 8 times 6. And then the height of the prism is 10. So 1/2 times 8 times 6 times 10. 240. Cubic miles.
Why is it in miles?
I don't know. The cone. So this is going to be the area of the base times the height, and then you divide it by 3 because it's a cone. Cones and pyramids are divided by 3. So we treat it, huh?
Can you say that again?
The area of the base is pi r squared. So our radius is 12. The height of the cone is 24. And then we divide by 3 at the end.
Why can't we just say
And you should get 3,619.11 cubic yards. All right, 61. This is a pyramid. So the base of the pyramid here is a square. So the area of the square is 5 squared. The height of the pyramid is 4. And then we got to divide by 3 because it's a pyramid. So we get 33.33 cubic meters. All right, now we have a sphere. So the volume of a sphere is 4 times pi times r cubed divided by 3. Your radius is 7. So you must do that first. 7 cubed is 343 times pi times 4 is 4310 divided by 3. 1,436.76 cubic yards. Surface area. Surface area of a sphere is 4 pi r squared. So 4 times pi times 11 squared. So 11 squared is 121 times pi times 4 gives you 1,520.53. And that's square kilometers.
The formulas that are on this paper are true, because they're not right. Adds extra
64.
doesn't tell us.
Again, we want surface area. So it is the area of the base plus the area of the top part of the cone. So that gives you the formula up above there. So the radius is 9. And the slant is 20.1. So 81 times pi. And we have 9 times pi times 20.1. So add those together, and you should get 822.78 square miles. There's your vocabulary. Vocabulary. Triangle segments, altitude, median, angle bisector, anything on there that you don't know. Good.